Hello everyone, the title of my presentation is a deep learning approach to model pseudo-measurements in active distribution power networks. We are attending from Montana State University, the Department of Electrical Engineering. My name is Sefid Radush and I'm going to be the presenter during this presentation. Our team members are Mariam Bahrami Panoh and Hashem Nehri. First, a little background on our work. One of the challenges in distribution network is the lack of real measurements that leads to the poor observability of these networks. Moreover, the conventional methods for the generation sub-measurements are not very powerful in large-sized power networks, and overfitting issue is not addressed in the existing database sub-measurements modeling. Therefore, we address these challenges in our work properly by generating smooth measurements from a limited number of available measurements in active distribution networks to make the system observable. Dropout technique is used as a regularization to prevent overfitting, and hyperparameter optimization with a grid search is used to tune dropout rate. And at the end, 1 year data on every early frequency is used to train and test the model. Here you can see our methodology. Coupled cross-validation is used to split data for train and validation set in order to evaluate the model. The value of K is chosen as 5. Drop-up technique is used for regularization and it can be used in an input and hidden layers, and some neurons are dropped out during the training. We applied the drop-up technique to hidden layers, and each hidden unit will be 0 out with probability P. In order to choose an accurate dropout rate, a hyperparameter optimization with grid search is used. And other parameters of deep neural network parameters are mentioned in this table. A stochastic gradient descent is used as an optimizer. The number of hidden layers are 5. Rectifier linear units are used as an activation function in hidden layers, and a linear function is used as an activation in output layer. Uniform is used as a kernel initialization, and the dropout learning rate are 0.2, 0.4, 0.5 for the first, second, and third hidden layers, and the number of training epoch is 100. In this study, we consider IEEE 13 bus distribution network as a case study. We consider one PV on the bus 7, and we assume that P12 and Q12 as an input for deep neural network, and our output is P and Q injection on our buses. First 6-month data is used for training, and the remaining ones are used for evaluation the model. We evaluate our model in 2 criteria, mean average error and root mean square error, and we compare our result one of the existing method that is used, feed forward artificial neural network, and also we compare average and a standard deviation of for 2 buses as an example. And as it's clear from 2 tables, the results obtained from the proposed method show much reduced error than those existing ones in the literature. And as a conclusion, the result of deep neural network method in terms of MAE and RMSE are improved compared with artificial neural network, and the average and standard deviation in buses are improved in the new approach. And as a recommendations in the future, the proposed model will be tested on the large unbalanced distribution networks. The new model will be designed to generate smooth measurements and detect any errors on the input measurements. And the mixed types of loads will be considered on each bus to evaluate the performance of the training model.